to start with the to-do list. There is homework due tonight. This would be homework number 11. Homework number 12 is due next week on Tuesday, and that's your very last homework assignment. We're almost at the end of the semester. We're in week 14. Week 15 is the last week of instruction, in which, oh no, I was gonna give you guys a quiz. I'm pretty sure I'm not supposed to have any quizzes or exams due during that week. Well, let's at least list the homework that you need to do. And I plan to do a grade update this week so that way you can make up any missed assignments after you've seen your grade. Homework 12 is due next week. That's your last homework. On the 7th. So on the 7th, well, next week on Tuesday, we'll either finish today's notes, but if we can get through all the notes, then we'll go ahead and start reviewing for the final. Spend next week getting ready for your final exam, and you'll be working on that exam during finals week, the week 16. Okay, so if I gave you a quiz, which I was hoping to help your quiz grade a little bit, but it would be due during the last week of instruction. I don't think there's time to do any more quizzes. So if you missed a quiz, let me know. Please make up those assignments. I can't, I don't feel right giving you one during all the finals that you're studying for. Okay, so no more quizzes. Okay, so we need to do notes for homework 12. This is the last set of notes for homework. If we can't get through all of them, we'll finish next week, but then after that, start to review for the final exam. And also at that time, I'll have a better idea of what this test will look like. I haven't really made a draft yet, so we'll see. Notes for homework 12. So for the end of homework 11, we start to look at functions. I'm going to restate what a function is in a function which I'm going to call f. As an input, we call x. And only one output, y. And I know it looks kind of weird, but sometimes we call y f of x. They mean the same thing. Parentheses x. So your input is inside the parentheses. You input x, and the whole thing, f of x, is the output. We could replace with y if you want to. So let's do an easy one really fast. Oh, sort of easy, maybe. Let's say y equals let's do x squared. Another way I could write this, like the same exact example, is having f of x equal x squared. So y is the same as f of x. You input x, output y. Or in here, you input this x, for that x right there, and the output is the whole expression, f of x. Okay. Let's make a little table, draw a part of the graph. Table for inputs, we input x and you output y, which is x squared. We're going to use a few values of x to get a kind of sketch of what the graph looks like. I would pick some negative numbers. A good number to pick sometimes is 0, and then some positive numbers. We'll do -3, -1, 0, 1. There's nothing special about 3. I could have picked 2. I could pick -1/2 and +1/2. Just trying to pick a few inputs, get my outputs, plot those points, and then connect them to get an idea of the graph. Right. We put -3 in for x. We're going to take -3 and square it. Here, take -1 as your x value. It's going to be squared. 0 squared is 0. 1 squared is 1. 3 squared. Let's put some units on the graph. Try to space them out like the same distance apart. -3 for x. More works on here if you want. So this would be a point. This is a point x, y. X is -1, y is +1. This would be the point 0, 0, x for 0, y for 0. And then x is 1 and y is 1. And x is 3, y is 9. So I have seen these before and kind of taught this before. These are parabolas. So you want to connect from this, what's called a vertex, and swoop this way and have it be exactly the same on the other side. You could also find that by just finding more x values, getting more points to see that this is going to curve and be symmetric through the origin. This side's going to match that side. Okay, so this is kind of, well, it's called sometimes a parent function, and it's sort of what I would think is an easy function. You kind of know how to put your input in and then what to do next. The next one's not, it is also kind of a parent function, but it's not very easy in a sense. It's called an exponential function, and the input x will end up being your power. So let's try. Let's try y equals, let's do 2x, 2 with the power x. Okay. Or if you could have, instead of y, replace it with f of x. That's going to be 2 to the x. So this is the same exact thing as this. I kind of like this way better. F of x, so your input is x, and whatever you put into the function f is going to end up here as a power on 2. So put in x equals 1, it's going to be power 1. Put in x equals 5, 2 to the 5th. X equals -8, 2 with a power of -8. So when you put x in, it's going to go up here into the exponent. Let's make a table. Do it on the other side. So I suggest usually picking x equals 0, maybe some negative numbers and some positive numbers. There's no correct amount of numbers or like the right number to pick. You're just trying to get a good sketch of your graph. I picked -3, -2. -1 and 0. +1, +2. I think that's probably good enough. We could do 3, we could do more, but let's start here for now. Get all of the outputs. Okay. So if you input, go. Question. Oh, cool. Yeah, let me write that down. And also, if you want to be sure that I do that, send an email, but I'll make a note. Cool. I got it. Thank you. Maybe we'll just work this out in each little space here. So we have input -3, and that's going up here as your power of -3. Start to simplify 2 to the -3rd. Take care of that negative exponent. I bring this down into the denominator, 1/2 to the 3rd. 1/8. And here, you input -2, and then the output is y equal to 2 and the power of -2. Then you want to simplify this. First start with the negative power. By bringing this down, it's 1/2 squared, so 1/4. Then input -1, output would be 2 with a power of -1. Again, take care of the negative exponent. So we have 1/2 to the 1st, or 1/2. Two with a power of 0. You're inputting 0 right there. Anything with a power 0 except for 0. Any non-zero number with power 0 is 1. Okay, then you're putting in x equals 1. 2 to the 1st is 2. And then input 2. Base 2 now has an exponent of 2. Which is 4. So we're setting up our graph. X values are here. Ooh, y values this way. And from each, let's see, row of the table, there's a point. The point -3, 1/8. X equals -2, y equals 1/4. This pair, this pair, this pair, this ordered pair, x, y. Okay, median x. So over to -3 and then up +1/8. So you're really close to the x-axis, but not touching it. It's still underneath this little marker for 1. Like just above the x-axis. Over -2, we want +1/4, which is more than 1/8, so it needs to be a little higher than the previous y value and over here, but also still less than 1. Just a little bit higher. Okay. And then over to -1, +1/2. It's like basically next to that. Okay, cool. Then 0, 1, be 0, up 1, up right there. 1, 2, now we're going to go up quite a bit. 2, 4, over 2, jump up. Let's do one more. We'll put in 3. Get out 2 cubed, which would be 8. So from x equals 3, we're going to go up to right here. So this is a smooth function. It's never going to cross the x-axis. You're just going to get closer and closer and closer. Goes through 0, 1, and then jumps up really quickly, exponentially. So we're going to connect these and grow. And it keeps on going up larger and larger y values as x moves towards positive infinity. And then smaller and smaller y values this way, but still positive outputs as x goes to negative infinity. Okay, now that we've seen what these functions look like, we're going to just practice getting certain kinds of outputs. So in the first example, we have 2 functions. Before that, I just found I have a definition. So we're going to define all the parts of this kind of function. Okay, so it can be written as f of x equal to b to the x where b is not equal to 1 and b is a positive real number. So b is a real number. I'm just kind of saving some writing, but also b is greater than 0. It's positive. We're going to look at f of x equal to 4 to the x, and g of x is 1/2 to the x. Okay, so I'm going to make a bunch of parts. Part A. Let's find f of -1. So input -1, and that's going to go into the exponent on whatever your base is. So it's going up here, the base for this function. So first of all, you want to pick the right function. So f of -1. Find the function f. This one. Right function. Now for your input x, it's going to be -1. And that x value right there goes up into that power. Okay. And we're going to just keep simplifying that result. Take care of the negative power first. And 1/4 to the first, so 1/4. Okay, next we're doing g of 2. So scratch work. First, check out the function. You're looking at function g. So we want to use the function with g of x, which was 1/2 to the x. Okay, and the input is 2. So if you have x equal to 2, it's going to be going up here as your power. Take your base 1/2, raise it to this input of 2. So you have 1 squared over 2 squared. 1 squared is 1, 2 squared is 4. Oh, it's cool. That's interesting. We got different inputs and the same outputs, but also these are totally different functions. So the graph of one is separate from the graph of another. So if you were drawing a sketch of f and g, one would have its own graph, and then there would be another graph, probably would cross it somewhere. Okay, let's just stick with inputs and outputs. Let's input 0 through the function f. Find the right function. Use and then you're inputting 0. So f of 0 means have your x value equal to 0. To put in x equals 0, you get out form 0. Any non-zero number raised to the power 0 is 1. Okay, one more for this example. Let's get g of -3. Okay, so first get the right function, g. Which is where we take 1/2 and put it to power x. Okay. Then you're putting in -3 for your input. So if you take g, extended -3 for x, you get out 1/2 with the power -3. So now we just have to figure out how to simplify this 1/2 to the -3. What I would do, and there's many, you could do your own way, we'll reach the same answer if you follow the right rules, is take care of that negative power, that negative part of your power. So you're going to bring this whole thing underneath 1 and have a positive power of 3. So we're going from there, 1/2 to the -3rd to here, 1/1/2 the positive 3rd, or +3 as its power. So it's a bit messy, but I still feel more comfortable simplifying it this way. I've got 1 in the numerator. It's over 1 cubed divided by 2 cubed. So I have this 1 in the numerator. Divide by 1/8. I'm going to take that top number, multiply by the reciprocal of the bottom fraction. So when you divide by a fraction, we multiply by the reciprocal. What we're dividing by. So we got 8. Okay. So one more example where we have 2 different functions, and we're going to look at certain outputs from those functions. So the first one, so your first function is called f, and f sends x to 3 to the x. The other function, g of x, is going to be 1/5 to the x. And then we're going to just find the following outputs. Okay. It says f of -2. So put -2 into the function f, see what comes out. And I know, again, it looks kind of weird, but when I look at this, just the number -2 is the input. The whole thing, f of -2, is the output. All right, let's try. Okay. First, pick the right function. You're using the function f. Okay, and then you pick the right x value. They're telling you to let x equal -2. Put in -2 for x, you'll get out 3 with power -2. And then you just need to keep on working with this number, get it simplified. Take care of the negative exponent. It's all underneath 1. So 1/9. F of -2 is 1/9. Input -2, output 1/9. Okay. Okay, we're going to look at f of 2 plus g of 2. Oh, it's f of 2 plus g of -2. So what you want to do is just find this output from the function f, separate, kind of like on its own. And then you're finding the output of putting -2 into the function g, then add them together. So I wouldn't manipulate this because it doesn't work for every function to have some kind of step that you do with. Anyway, what I would do is just, you're putting this input through that function, put that input through that function, then add them together. That's okay. I think that's the best way to make sure you don't make any assumptions that aren't true about your function. So we're getting that's your function f, and then put in power 2, add -2 into the function g. That was taking 1/5 to the x. So you have 1/5. And then input -2 right here. So there's my f of 2. And then there's that plus sign copied down. And then g of -2 is right there. Okay. 3 squared is 9. And this piece, I would take care of that negative part of your power first. So I'm going to bring all of this underneath 1 to the power of positive 2. Okay. We have 9 plus 1 over. And then this part in the denominator, I'm going to write as 1 squared over 5 squared. Okay. 1 over 1/25. So we're going to take 9 and add this 1 in the numerator multiplied with the reciprocal of the fraction in the denominator. So 1 times 25 over 1. Or 9 plus 25, which is 34. So far, let's do one more part. So we will do part C. This time, let's do, it's going to be similar, but it's f of 2. Subtract g of -2. Okay, kind of like I was mentioning in the other example, there aren't, sometimes you can use rules for just like, sometimes you can use certain rules for functions, but not always. So it is not the case that that negative and that negative cancel. That's not what you want to do. What you want to do is just copy this negative sign down. Just have this minus between this number, which is f of 2. So go find the output for x equals 2 through the function f. Get that value, put it right here. And the function f was 3 to the x. So you take 3 and put in x equals 2. Okay, just got down there. And then here, this is g of -2. So put -2 into the function g. That function was 1/5 to the x. So take 1/5, put it to the power of -2. I know we just did this, but it couldn't hurt to do it again, just to make sure it's clear. Okay, 3 squared is 9. Now we have a minus sign right here. And then for this 1/5 with the power of -2, I'm going to go through the steps again, take care of that negative power, bring everything underneath 1, give it a power of +2. Now that power is going to go to the numerator and the denominator. So 1 squared over 5 squared is right here. 9, subtract 1 over 1/25. You divide by this fraction. What you want to do instead is multiply by the reciprocal of it. So 9 minus 1 times 25. Which would be right here, it's 25. If you want, you can put 1 over 1. It's like a lot of ones now. You can have like these cancel or something and then have 25 over 1. It's like too many ones. Anyway, 9 minus 25 be negative. Pretty sure it's negative 16. Before we talk about the next idea / rule, it turns out that these exponential functions are what we call one-to-one. And because of that, we get the result where we can say exponents are unique. So you still need the same setup for your exponential function. We need the base to be, which this time we're going to call the base A instead of B. It needs to be positive and it cannot equal 1, and it's a real number. So it's A is greater than 0 and A does not equal 1. If A with power x is equal to A to the power y, so you have a matching base of A, this exponent, and that exponent, they have to also match. X has to equal y. Okay, if you see A to the x equal to A to the y, it must be the case that x is equal to y. Let's try an easy one. Okay. 7 cubed is equal to 7 to what power? The same base of 7, powers have to match. You have to have x equal 3. Okay. Right, so solve, and this time we have 16 equal to 4 to the x. So We want to manipulate this, try to see if we can have the same base. And either we're going to be able to get a base of 4 or a base of 2. Might do this problem 2 different ways just to kind of explain the process. So one way I can look at this is 16 is 4 times 4. So what I've got is 4 squared on this side. And over here is 4 to the x. Base of 4, they have to have matching exponents. So x has to be equal to 2. Or 2 equal to x, same thing. Same problem, but I'm going to fully factor like both sides, get the same answer. So I could do 16 is like 2 times 8. 8 is 2 times 4. 4 is 2 times 2. And on this side, I would also factor so 2 times 2. So 16 is 2 to the 4th. And then equal to, we're going to rewrite 4 as 2 squared. And then it had a power of x. One more step. 2 to the 4th equal to 2. And when you have a power to a power, you multiply those numbers together. So the base is 2 and the power is 2 times x. Okay, now I can use the rule. I have a matching base of 2, so I have to have matching powers. I have to have 4 equal to that 2x. And that's because x1s are unique, or the result that I just wrote down earlier. That exponent has to be the same, equal to that exponent. It is equal to 2x. Solve for x by dividing both sides by 2. I get x equal to 2. Which is what we had before. Okay, next one. We're solving for x. All right. 10,000 equal to 10 to the x. Okay, I'm going to kind of taking a step back and looking at the problem. I'm going to be able to use base 10. I can write 10,000 as 10 to the 4th. And then I'm just copying this part down. 10 is my base, has a power of x. Okay, if I have 10 to the 4th equal 10 to the x, the same base of 10, those exponents have to also be the same. I have to have x equal to 4 or 4 equal to x. Using the rule that we've just gone over for exponents. Doing another one of these, solving for x. And it's got 9 equal to fraction 1/3. And this has power x. Okay, so just kind of letting you know what I sort of thought when I looked at the problem was, I know 9 factors into 3 times 3. Maybe I want base 3, but then kind of didn't really like the rules that followed after that. So then I went for a base of 1/3, like this one over here. So we're going to try to get this 9 to somehow look like 1/3 to a power, and then use the rule for the powers that they have to match. So let's start with this. 9 is 3 squared. And up here, copy down the 1/3 to the x. Okay, and again, what I chose to do is try to get a matching base of 1/3 using exponent rules over here. So I could write that as a power of -2, and that would bring this under the denominator, and then I would get closer to having a fraction. So next step is to bring this underneath 1, and then the power would become -3 with a power of -2. And it's equal to 1/3 to x. Again, this is now 1/3 to the power of -2. Okay. And what I did is kind of a trick. I know that if I raise 1 to any power, it's still going to be equal to 1. And I picked the same power as this one, so that I can then bring that power out as an exponent on a whole fraction. Anyway, I have this 1 is the same as 1 to the power -2 over 3 with power -2. This side is 1/3. I have 1/3, and the whole thing has power -2. And then copy down. Oh, I probably want an arrow. Like this, then this, then this part, then this part, then this part. Copy down that side. Okay, cool. I've got a base of 1/3. 1/3, 1/3. This power x must equal that power, -2, using the rule for exponents. Okay. There's one more. So we're going to solve for x. So 1 over 32 equal to 2 to the x. So I'm going to try to, well, of course, I'm going to factor 32, try to manipulate this side and somehow have it as this kind of base of 2 to some sort of power. And then we'll use the rule for exponents. Okay, let's see, 32. Is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. So it's 2 to the 5th. Next step, and what happens next is we have 1 over 2 to the 5th. Equal to 2 to the x. And we're going to bring this up into the numerator and make that power negative. So 2 to the negative 5th. And that equal to 2 to the x. Awesome, I've got a matching base of 2. So now the exponents have to match, and we need negative 5 to be equal to x. Or x equals negative 5. Okay, cool. I can introduce log functions. We'll practice changing from log form to exponent form, or the other way around, and probably have to practice solving, I guess, a log equation for x, which I don't know if we'll have time for that last part today. Okay, so a log function is the inverse of an exponential function. It has some of the same requirements as your exponential function, and part of it has the word log in it. The full word is logarithmic. Okay. All right, let b be greater than 0 and not equal to 1. Okay, and also the domain of this function, the set of inputs, is going to be only positive numbers. So your x values have to be greater than 0. There's two things, they mean the same thing. So we're going to put them like one on top of the other. and use a double-sided arrow means, so it's like one implies the other or back the other way. So first one is y equals log base b of what's called the argument x. Okay. This function is equivalent to, or we're going to put a double-sided arrow, having b to the power y equal to the argument x. All right, so this is called exponential form or exponent form. And then when it's got the log as part of it, it's called log form. So the homework might say write it in log form, so write it like this. If it says write it in exponential form, you're taking this expression and writing it like that. And I've been practicing it like you take your base, hook over to what everything's equal to and have that as your power, b to power y, so to equal to the input x, or the input, it's called the argument. So what's inside parentheses, it's all equal to that. Okay, I think we have some time to practice. We're going to write the following in log form. All right, it's 3 squared equal to 9. So this is equivalent to having 3 as your base, so log base 3. What goes in parentheses is what that thing with the power is equal to. So this 3 with power 2 is equal to 9. 9 goes in here. Equal to the power 2. And double check if I take 3, raise it to a power 2. Is that equal to 9? Yes. One more. It's having 2 to the negative 5th equal to 1 over 32. So usually find whatever is kind of a base that has an exponent. That base is the log base 2. Of 1 over 32 is equal to the power negative 5. Okay, I think that's good for today. next time we'll practice writing in exponential form, and then we'll do a few problems where we practice solving equations that have logs in them. And that's it. So meet next time to finish these notes. Thank you for coming to class, especially those of you who are actually in the meeting. I really appreciate it.